Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed about the measurement of the length. How we can measure the smaller distances like a size of the atoms and the size of the molecules. As well as we understand in the previous video that is the measurement of the larger distance. How we can measure the distance between the earth and the planet. How we can measure the diameter of the planet, and we were understand about a range of the length. The range of the length in the physics is from the 10 raised to minus 14 meter, that is the size of the nucleus, to the 10 raised to 26 meter, that is the observable galaxy. So dear student, now in this video we will discuss the measurement of the another fundamental physical quantity, that is a mass, right? How we can measure the mass, smaller mass like a mass of the electron, mass of the proton, that other is the larger mass like a mass of the sun, mass of the planet, mass of the earth, that all the things we will discuss in this video. So dear student, let us start with the measurement of the mass. So before to measure the mass of the object, what is the mass? Mass is, we can say that the mass is a weight of the body. No, mass and the weight is a different thing. Mass is the basic property of the matter. Mass is the inner measurement of the inertia of the any object. So this mass of the body does not depends on the other external factor like a temperature, pressure, or the location in the object, location in the space, right? So the mass does not depends on the factors like a temperature, pressure, humidity, right? Or the place where the object is there. So dear student, mass is the internal property of the matter. How we can measure the mass of the body? In which unit the mass of the body is measured? What is the unit of the mass? The SI unit of the mass is kilogram. Generally, we measure the mass of the object in a kilogram. But for the atoms and molecules, the kilogram is an inconvenient unit because the atom, molecules, electron, proton has a very small mass, right? It has a very small mass, so it is a inconvenient to measure the mass of the electron, mass of the proton, mass of the atom in a kilogram. In that case, we use a standard unit of the mass, that is called the unified atomic mass unit. So the mass of the electron, mass of the proton, mass of the molecules, mass of the atoms, and the smaller mass we can measure in the unit called the unified atomic mass unit. It is represented by a small u, or sometimes it is known as the AMU, atomic mass unit. So what is the unified atomic mass unit, and how we can define the unified atomic mass unit? So let us see that the unified atomic mass unit is equal to 1 u is equal to 1/12th part of the mass of an atom of a carbon 12 isotope C612, including the mass of the electron. So atomic mass unit is defined as a 12th part of the mass of an atom of the C612, including the mass of the electron. Dear student, here we know that in the carbon isotope C612, how many protons are there? 6 protons are there. How many neutron are there? 6 neutron are there, and electron are also a 6, right? So the unified atomic mass unit, or AMU, is defined as the 12th part of the mass of the carbon C612, including the mass of the electron. So how much AMU? How we can measure this mass of the electron, mass of the proton? That is measured in a AMU, right? And the one AMU mass it is equal to 1.67 into 10 raised to minus 27 kg. 1 AMU or 1 unified atomic mass unit is equal to 1.66 into 10 raised to minus 27 kg. It is actually 1.666666. In some textbook it will be taken as a 1.67 into 10 raised to minus 27 kg. That is the mass of the one proton, mass of the one neutron, right? We can also get, because in the carbon isotope there are 6 proton and 6 neutron are there. So we get the total atomic mass of the carbon isotope is a 12th part of the total atomic mass, that is the mass of the one proton. So dear student, here the mass of the one proton is a 1 AMU. It is actually 1.007 AMU and it is equal to 1.66 into 10 raised to minus 27 kg. So dear student, understand that. Now how we can measure this mass of the different objects, smaller object. So methods of measurement of the mass. How we can measure the mass? Simple object. Simple method to measure the mass is using a weighing machine. By using a weighing machine or a simple balance, we can generally measure the mass of the object. It is a 1 kg, 2 kg, 500 gram, 250 gram. We are comparing with the standard weight and measuring the mass of the substance. So simple method to measure the mass of the object is using a weighing machine, or we can say that the simple balance. But dear student, mass of the electron, mass of the proton, or we can say that the mass of the planets, stars and earth, we cannot use this weighing machine or a simple balance, right? So for that a special technique is used to measure the mass of the object. First of all, we will discuss the how we can measure the larger mass. For example, the larger mass in the universe, like a mass of the planets, mass of the stars, right, are calculated or can be measured with the help of the Newton's law of gravitation. Dear student, you know the Newton's law of the gravitation. In the first chapter, we were discussed about the Newton's law of the gravitational. So what is the Newton's law of the gravitational? The gravitational force between the two objects is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. So from the formula of the gravitational force, F is equal to G m1 m2 divided by r square, where capital G is the universal constant of the gravitational, 6.67 into 10 raised to minus 11, right? M1 and M2 is the mass of the both the object and R is the distance between them. So according to the Newton's gravitational law, or we can say that the formula of the Newton's gravitational law, we can measure the mass of the sun, mass of the planet, mass of the stars, right? So this we will discuss in the chapter number 8, right? So now it's a turn to measure a smaller mass. For the measurement of the smaller mass, like atomic mass, subatomic mass, mass of the electron, mass of the proton, right? Smaller particle, mass of the smaller particle is measured with the help of the technique is called the mass spectroscopy, right? And the instrument which measures the mass of the electron proton, that it is called the mass spectrometer. So dear student, for the small measurement of the small masses like atomic and the subatomic particles such as electron, proton, neutron, we make use of the mass spectrograph, in which the radius of the trajectory is directly proportional to the mass of the charged particle moving in the uniform electric and magnetic field. So in the mass spectrometer, right, when the electron is enter into the mass spectrometer, it moves in a circular path and the radius of the circular path is directly proportional to the mass of the charged particle. So if we enter a heavier charged particle on the mass spectrometer, the radius of trajectory is a larger, and if we enter a smaller particle having a mass small compared to the other particle, the radius of the trajectory is a small. This method was first established by the J.J. Thomson and firstly found the ratio of the charge of the electron to the mass of the electron, right? And from that the mass of the electron to be calculated by a charge of the electron divided by mass of the electron, and from that the mass of the electron can be calculated. It is equal to the 9.1 into 10 raised to minus 31 kg. So dear student, here the mass of the electron is a 9.1 into 10 raised to minus 31 kg. So dear student, understand the techniques to measure the mass of the smaller object as well as the mass of the larger object, right? So here the range of the mass is also a very wide. From the mass of the electron, it is about a 10 raised to minus 30 kg. In the range of the 10 raised to minus 30 kg to the mass of the galaxy, that is a range of a 10 raised to 55 kg. So here the mass of the objects we come across in the universe vary over a wide range, right? So the range of the mass varies from the small mass of the electron like a 10 raised to minus 30 kg, that is the mass of the electron, to the very large amount of the mass, that is about a 10 raised to 55 kg. So dear student, in the textbook also the range and the order of the mass is given to you, but it is only for the information. No need to remember this table. Here we can say that the mass of the electron is of a order of the 10 raised to minus 30 kg. Mass of the proton is 10 raised to minus 27 kg. Similarly, mass of the red blood cell is about a 10 raised to minus 13 kg. Mass of the raindrop is about a 10 raised to minus 6 kg. Mass of the human is about a 10 raised to 2, right, in order of the 100, right? Similarly, larger mass, we consider the mass of the earth is about a 10 raised to 25 kg, right? Mass of the earth is a 6.6 into 10 raised to 24 kg. Mass of the sun is a 2 into 10 raised to 30 kg. So here the range of the mass is also a very wide. So dear student, understand about the measurement of the mass. Now we can understand the measurement of the time, right? Everyone knows that how we can measure the time. The time is measured using a clock. What is the unit of the time? Time is measured in a second, hour, minute, right? Day, week, year, right? Calculate. 1 year is equal to how many second, right? So normally the time is measured using a clock, right? So smaller time in a microsecond, millisecond also we can measure with the help of the atomic clock, or we can say that the cesium clock, right? So as a standard, atomic standard of the time is now used, which is measured by the cesium, or we can say that the atomic clock. In the atomic clock, a second is equal to the 91926311770 vibration of the radiation from the transition between the two hyperfine levels of the cesium 133 atom. In the cesium 133 atom, the vibration of the atom can be measured, and it is equal to the 91926311770 vibration, and the time for the one vibration we can measure. So cesium clock works on the variation of the cesium atom, which is similar to the vibration of the balance wheel in a regular wristwatch and quartz crystal in the quartz wristwatch, right? So similarly we use a simple pendulum clock, right? Dial clock, right? Wristwatch clock, crystal quartz clock. So different types of the clock are used. Nowadays we use a digital clock also. We can measure the 100 parts of the second. This digital clock is used in the race, right, to measure the accurate timing. So the national standard time and the frequency is maintained by a 4 atomic clock. Indian standard time is maintained by a cesium clock at the National Physical Laboratory, New Delhi. Cesium clock are very accurate and the uncertainty is very low, a part of a 10 is to 13, which means not more than 3 microseconds are lost or gained in a 1 year. So accuracy of the cesium clock is a very high, right? Very accurate. Atomic clock is a very accurate. There will be some loss or gain. It is a not more than 3 microsecond in a 1 year. So dear student, understand about the atomic clock. Similar, a table range and order of the time interval or the measurement of the time is given in the textbook, right? So the range of the time in a physics is a 10 raised to minus 24 second to the 10 raised to 17 second. So if we consider the lifespan of the most unstable nucleus is about a 10 raised to minus 24 second, right? And the age of the universe is about a 10 raised to 17 second. So the range of the time is also very wide. So dear student, in the physics, the range of the length, range of the mass, range of the time is a very wide. So we need to measure accurately the time, length and the mass of the object, right? So dear student, I hope that you understand about the measurement of the length, measurement of the mass and the measurement of the time.